Okay. This is the second part of my lecture about the determination of volume of a solid of revolution. So, part one was about the circular disk method. Okay. Now, the second method is the circular ring or washer method. Okay. So, you can just imagine what a washer is, uh, or a circular ring. Now, suppose we have this area, eh, and you want to revolve this area about the x-axis. Now, in order to get a circular ring or washer, the strip must be perpendicular. Yeah. Same with the circular method, circular disc method, the strip must be perpendicular to the axis of revolution. But sa circular disc, one end of the strip must touch the axis of revolution. But for cases wherein the end will not touch the axis of revolution, there will be a space. Okay? So let's consider a vertical strip. No? So the strip is perpendicular to the axis of revolution. But this end, it does not touch the axis of revolution. Therefore, if you will revolve this strip about the x-axis, there's a hole sa inner portion of the disc, like this one. Okay. So, there's a hole sa middle na part. No? So, what's the volume of this? Eh? What's the volume of this? Oh, it looks like a washer. Ba? So, again, sa area between curves, our assigned parameters are this one, y up and y down. So this will be y up. The outer radius, this is still a circular disc, but we have to subtract this smaller disc. No? So the volume of this is volume of the bigger disc minus volume of the smaller disc. Our outer radius is y up, our inner radius is y down. And so we get this one. Our thickness dx. So this will be our differential volume. Okay, volume of the bigger disk is pi y up square dx. Volume of the smaller disk, circular disk, is pi y down square dx. Okay? It's simply pi r squared, ba? Dx. And we combine pi and dx, so we get this one. Simplified na formula sa differential volume. Okay? Okay, this illustration. We have this area and we want to revolve this about the y-axis. So again, the strip must be perpendicular. No? So we'll consider a horizontal strip. But when we want to revolve this rectangular strip about the y-axis, 9 holes inner part, like this one. And so the volume disk again is volume sa bigger na disk minus volume of smaller disk. So we are going to get the outer radius and the inner radius. And we will use our notation sa area, x right and x left. So therefore, our outer radius is x right and inner radius x left. And thickness dy, this is our differential volume. Same lang, no? Pi outer radius square dy minus pi inner radius square dy. So remember this formula. when you get a circular ring or washer method after assigning a rectangular strip. Okay. Let us solve this problem. Find the volume of the solid generated by revolving the region bounded by the curves y squared equal to 4x and y equal to x about letter A, the x-axis, and then letter B, about the line x equal to 4. Okay. So first is your graph. Y squared equal to 4x is a parabola opening to the right. And you have this one. Okay. We'll just cut here. Y equal to x is a line having a slope of 1 and it passes the origin since our y-intercept is 0. From the standard form, y equal to mx plus b. So since it passes to the origin, then this is our line. So this is our region. And letter A, we are going to revolve this about the x-axis. And then letter B, about the line x equal to 4. Okay. So letter A, let's revolve this area about the x-axis. So to get a circular ring, our strip must be vertical. Okay. Para perpendicular siya. So vertical. And so we have y up and y down. And then thickness dx. So pag revolve, our outer radius is y up, our inner radius is y down with thickness dx. So our differential volume is this. Pi y up squared minus y down squared dx. So we integrate, okay? We integrate, So we'll replace y by x kay dx man ta. So y up, our y up is parabola, blue. So we solve for y. And then y down is green, straight line. But since dx, our limits must be values of x. One point of intersection is the origin, and then this point. So what's the coordinate of this point? So let's locate the points of intersection. What we will do is we equate. No. Now, since we have y squared and y, okay, you can equate y or you can equate y squared. Y squared equal to y squared. So for this one, y squared is equal to x squared. And you have this y squared equal to 4x transpose 4x and then factor out x. Okay. So same sa video about area between curves as I explained that for a product of two factors to be equal to 0, one of the factors must be equal to 0. So it's either x is equal to 0 or x is equal to 4 para 4 minus 4, 0. So 0, x equal to 0, and here x equal to 4. So this is 4, 4 because y equal to x. So when x is equal to 4, y is equal to 4 also. So this point has coordinates 4 and 4. So let's go back to this. We integrate our limits, a limit from 0 to 4. Okay. Take note that y up squared na. And our up is blue. Parabola. Squared man eh. So 4x lang. Diba? No need to square kay square man daan. But for y down, our down is green line. Y, our y is x and then square. For this one, no need to square 4x kay y squared man. Y squared na daan. No? So 4x lang. And then we integrate just a simple power rule. We have this. Integral of 4x squared over 2. So you have 2x squared. X squared dx, x cubed over 3. And then evaluate upper limit 2 times 4 squared minus 4 cubed over 3 minus 0, 0, 0. And this is our volume, 32 over 3 pi. Uh, Letter B, we're going to revolve the area about the line x equal to 4. So line equal to 4. There revolve. So since our axis is vertical, straight must be horizontal para perpendicular. Now, let's be clear on this. Now, when you plot a point, you will always start from the origin. So, assigning y up, y down, x right, and x left, you must refer them sa coordinate axis. So, for y, you refer it from the x-axis. For x, x right, and x left, you refer it sa y-axis. Oh, like for this one, this is right, x right, and then x left. Oh, so always refer it sa y-axis. Pag vertical, y down referred sa x-axis. Y up, sorry, and then y down, it's all referred sa x-axis. Ayan. So this is x right from y-axis and then x left. Now, and this is 4, red, x equal to 4. So when we revolve this one, we get this. Okay, of course, net dy. Okay. Now, what would be our outer radius? Remember, this is x equal to 4. Center sa disk o sa ring. Okay. Outer radius is from the center to the outermost part. This one, from the center to the outermost part. And that would be 4 minus x sub left. X sub L. Oh. Oh, this is 4 minus, this is x sub L. Therefore, this outer radius is 4 minus x sub L. While the inner radius, this one, it's 4 minus x sub R. So this will be our outer radius, inner radius. So be careful about this one. No, it's not always x right squared minus x left squared. No, it just happened na sa illustration, the area is revolved about the y-axis. But if the area is revolved about a different line, and you must understand how to get the outer and the inner radius. Okay. But always remember that x and y will always be referred sa coordinate axis. Okay, so in general, this is our expression sa dv. dv, pi outer radius squared minus inner radius squared dy. So you replace outer radius by 4 minus xl and you replace inner radius by 4 minus x bar. Okay. Limits na to dy 0 to 4 also 4 man. So outer radius is 4 minus xl. 4 minus our x sub left, x sub L is parabola. Eh? O x sub L, blue, parabola. So what's the expression of x? So it's y squared over 4, this one. So, x lang na eh, 4 minus x squared it. Inner radius, 4 minus xr. Our xr is this one, xr, green. And our x right is simply y. And so we have 4 minus y. Next is you expand the two terms, and then combine similar terms. 16 will be cancelled, and then 2y makombine, y squared makombine. Okay, we have this one. And then using power rule, okay, we have this. And then evaluate lower and upper limits. This one. 4 raised to 5 over 80 is 64 over 5. 4 cubed is 64. 4 times 4 squared, 64 also. So, makancel 64. So, lower limit, 0, 0, 0. The answer is 64 over 5 pi. Another one. Find the volume of the solid generated by revolving about the y-axis, the region bounded by the curve y equal to x cubed, and the lines y equal to 0 and x equal to 2. So let's graph this one. This is the graph of y equal to x cubed. And line y equal to 0 is the x-axis, and x equal to 2 is a vertical line. And this is our region. Okay. So this problem was solved sa first method, but the condition was the area was revolved about the x-axis. This time, the area will be revolved about the y-axis. So therefore, our straight must be horizontal. Okay. So our take nota, our x right is simply 2. X right, x right, that's 2. And then our x sub left, simply x na. Uh, okay? So, the length of our strip is 2 minus x, although it's not needed sa volume. And we have thickness of dy. So, once the strip is revolved, okay, our outer radius is 2. You know, our outer radius. From the center up to this point, it's 2. And then our inner radius is x. Okay? And then you have dy. Then our dv will be this one. Pi outer radius squared minus inner radius squared. So to uh, integrate, okay, 2 squared is 4. We replace x by y. Oh. So from this one, y equal to x cubed. How do we get x squared? Okay. You can do this. You solve for x first. X is cube root of y, di ba? Or simply y raised to 1/3. X is equal to y raised to 1/3. So when you square x, you will also raise y, uh, raise, you will also raise y raised to 1/3 raised to the power of 2. So that becomes y raised to 2/3. Okay. And for our limits, dy from 0 to this point, it's simple, no? When x is 2, y is 8. Di ba? When x is 2, y is 8. So our limits We'll start from 0 to 8. Again, x squared is y raised to 2/3. And then power roll, and then you evaluate from lower to upper limit. And then simplify, this is the volume. Okay, so that's it. Again, uh, when in order to get a circular ring, first, the strip must be perpendicular to the axis of revolution. But one end does not touch the axis of revolution. So therefore, when you revolve the strip, there's a hole sa inner portion. So to get the volume, it's simply volume of the bigger disk minus volume sa smaller disk. So I hope that you have learned some things presentation. Thank you for watching.